So thank you, Colin, for the invitation. Can you all see my screen?
It looks
Yes.
good, yes.
Okay. So Colin invited me to give this seminar on a paper that was published last year. That's called Broadening the Scope of Anthropogenic Influence in Extreme Event Attribution. And what I want to underline about this list of co-authors is that two things. First of all, this comes from the last workshop we had of a cost action that was on compound events that was called Damocles, and we wanted to have one last workshop that was more tailored toward attribution. And in the discussions about attribution of compound events, one of the themes was that compound events can also be compound because they have several causes. And if we started talking about impacts, then those causes are not necessarily all related to the climate. And the second thing I want to say about this list of co-authors is that it's very pluridisciplinary. So we have people from geography, philosophy, climate science, more towards ecology too, and disaster risk management. And I think that's how we manage to have a discussion that's not only about climate, but also about other parts of anthropogenic influence that lead to severe impacts of extreme weather events. If you're interested in having more details than what I will say today, you can just check in Environmental Research Climate this paper. And yeah, so here what I'm going to talk about is more extreme impact attribution. So we go from the hazards, just looking at the meteorological part of the extreme weather events, to impacts. And impacts can be very different in nature. They can be impacts on human lives, on livelihoods, on ecosystems, on infrastructures. There are many, many different types of impacts. Some of them are easy to quantify, others are more complex to quantify. And with the development of extreme event attribution, in the recent years, we've had some start of having not only extreme event attribution that's really tailored to understand whether an event is different than it would have been without climate change, but to look at the impacts of these events and try to understand how these impacts are different because of the extra difference in climate that comes from anthropogenic climate forcing. So the way it has been done is, I think, well summed up by this figure from Mengel et al., where you have climate attribution. So you try to understand how anthropogenic climate forcing leads to some changes in the climate system. And then you have impact attribution to climate change. So from those different states of the climate system, what kind of impacts we can find based on those differences. So for example, in Mitchell et al., they're looking at the 2003 heat wave and looking at the extra mortality that comes from the difference in intensity of the heat wave that we had in 2003 in London and Paris. And you can do that with a lot of different impacts. If you have an extreme weather event that you can relate in its intensity or change in probability to anthropogenic climate forcing. And the thing with this way of looking at extreme impact attribution is that it's very logical, but it's also very linear, looking at what anthropogenic climate forcing does to impacts through this chain, this causal chain. And because it's very linear, the way it's shaped and framed tends to really put the highlight on the hazard more than on the other parts of what makes impacts happen, such as vulnerability and exposure. I will give one example where there's a crossing of exposure, vulnerability, and hazard that goes a bit further than this linear chain. It's from a paper on Harvey that was written by Smiley et al. And there they have a hydrological model that they can run for, and it will give them for those different hexagons, the number of houses that have been flooded, for the level of rain that was observed for Harvey compared to the level of rain that could have been without climate change. And what they do once they have done that is that they look at the type of people who live in those different hexagons. And this helps to know whether the people who were affected by this extra change in precipitation that led to bigger flooding, they belong to a specific group. And here the groups are defined as racial and ethnic groups. And you can see in red, those are the houses that would have been flooded anyway. In orange, you have the houses that have been flooded because of the effect of climate change. And then in green, you have the houses that weren't flooded anyway. And you can see that there's a surrepresentation of Hispanic people in those orange buildings. So that's a way to look at injustice in the exposure to hazards related to climate change. So the question here is, why does framing matter? And so there are several things to say about this. First of all, I just want to reiterate that extreme meteorology and extreme impacts are not the same. So this is a figure from Vanderville et al., where what she did was to look at how extreme weather events can lead to different types of impacts. So she did that with an impact model, which I'm not showing here, but basically having an extreme weather event doesn't necessarily translate into high impacts, and extreme impacts don't necessarily translate into extreme weather. And that's because impacts are at the crossroad between the hazards, vulnerability, and exposure, as you can see in this figure from the IPCC. And the thing when we do extreme impact attribution and put the highlight on hazard is that we can also feed a narrative that what causes the event is the hazard. But there's been a lot of work in geography in particular and in disaster risk management showing that natural disasters are not natural, meaning that they are the results of some choices that have been made, for example, in the way in urbanization where buildings are built or some things like that. And there's been some work since 1976 saying that we need to take the naturalness out of natural disasters. And that matters because the way we are going to put responsibility and showing causality tends to when you have very high impacts, tends to highlight someone who would be responsible. There's a paper by Mayana Lassen and co-authors from 2020 where they say that extreme event attribution can be used as a convenient means to escape blame for local disaster management. I'm not saying that's necessarily what happens, but that's a question that has been asked from a certain part of the social science community and disaster risk management towards the people who do extreme event attribution. And it matters because extreme event attribution is also one of the parts of climate science that has been the most mediatized and that can be used by different types of stakeholders. So here to go a bit more into details, I have some quotes from two papers. One that was from 2022, where they say that describing climate and weather as the cause of disasters can be misleading, since disasters are caused by pre-existing fragilities and inequalities on the ground. Analytic frames that attribute disaster to climate can divert attention from these place-based vulnerabilities and their socio-political causes. And to give some concrete examples, Mayana Lassen also worked on some floods that happened in Brazil, where in the paper that talks about specifically those floods, she says that we find that a variety of contextual factors compel environmental leaders and scientists in Brazil to avoid and discourage highlighting the role of climate change in national extreme events, and then that attributing such events to climate change, and by extension attribution science, can be ineffective for policy action on climate change and other socio-environmental issues in need of public pressure and preventive action, which is kind of not what we would think logically as attribution scientists. I think a lot of the push for more extreme event attribution is also related to this will to be useful and to try to go for more climate justice. But it's hard to balance showing the responsibility that is related to extra greenhouse gases emissions and showing the responsibility of local management and local decision makers. There's another paper, I'm forgetting the name of Grant et al., I think, from 2015, that's about climatization of natural disasters and looking specifically at Bangladesh as a case studies, where they show that the people who say that some of the catastrophes, such as cyclones or the salinification of Bangladesh, are the ones who link that to climate change are also the ones who are locally responsible for some of the damages because of the way they're managing the land. So I'm not saying this doesn't mean that we should completely stop doing extreme event attribution, but those are valid criticism. And what we came, like, our conclusion with our group of co-authors was that maybe we can also propose to have a more compound way of looking at anthropogenic influence on those events. And we were inspired by this paper by Anna Bastos and co-authors that's about compound ecoclimatic events, where anthropogenic activity can go through climate change that is going to have an influence on climate drivers, but it can also have influence on elevated CO2 or nitrogen deposition and management that will have an influence on ecological factors, and that both of those will have an influence on stressors. So stressors there can be extreme wind, heat and drought stress, fire, insect outbreaks that will have an influence on impacts. And the way we transfer that into our extreme event attribution, more climate science way of seeing things, is that anthropogenic activity can have an influence on hydroclimatic drivers. And hydroclimatic drivers would be any meteorological variable. And those hydroclimatic drivers can be affected by both anthropogenic activity and sources of variability. And then they will have an influence on stressors. So a stressor is something that's a bit more complex than a weather metric. So for example, soil moisture could be a stressor. And anthropogenic activity can also have an influence on exposure and vulnerability through adaptation policies. And exposure and vulnerability can have an influence on those stressors. For example, if I take back my example of soil moisture, irrigation can have an influence on that, and water management. And then those stressors will have an influence on impacts. And the blue box corresponds to the way I was describing impactful event attribution. So the first flow chart from Mengel et al. And then those red arrows would be a way to have a more complete description of what is happening due to anthropogenic activity. And something that's important here is that when we were writing this paper, we realized that the words hazard, stressors, impact vulnerability have very different definition from one community to another. And typically what we would consider as impacts in climate community could be considered as just stressors by disaster risk management community. So I'm giving those definition of what a hydroclimatic driver is, what a stressor is, what an impact is, but this can shift around the causality chain depending on what community is using this framework. I think I'm talking a lot. Yeah. Okay, so I will give two examples on how to use this framework. One will be more qualitative and the other is going to be more quantitative. So the qualitative one is about the Portugal fire that happened in October 2017. So just for October 2017, there were 200,000 hectares of burnt area and 50 fatalities. And it's within a record fire season that from June to October is the record of burnt area in Portugal and also record of fatalities. And Alexander Ramos, who is one of the co-authors of our paper, wrote a paper about specifically what happened in October 2017, which can be summed up with this flow chart. So there's a long-term drought that has an influence on vegetation stress. And on top of that, there's Hurricane Ophelia that's going to come along the coast of Portugal and lead to very to very extreme wind intensities. And there are fire ignitions that happen because of the weather forecast saying that was going to be a hurricane, and then it meant that there was going to be rain. And so the farmers did some fire ignitions because they needed that for their agriculture practices, except the hurricane didn't go through Portugal, it stayed along the coast, and that means that they had the high winds but no rain. And this led to wildfires that led to socioeconomic and ecological impacts. If I put that back into our framework, we have anthropogenic activity that's going to have an influence on heat waves, long-term precipitation deficit, extreme fire weather, extreme wind. I mean, it can or it cannot have, but that's some of the things that can be affected by greenhouse gases and aerosols. And there's a source of variability that's Hurricane Ophelia. And then anthropogenic activity also has an influence on exposure and vulnerability. So extreme vegetation stress, vegetation composition, high fuel load, fire season definition, warning system, evacuation failure, elder rural population living there, agricultural abandonment. And this combined to what I just explained about the extremely high ignition number led to the stressors that are mega fires and low soil moisture that will lead to impacts that are burned areas, biomass loss, poor air quality, mortality, infrastructure, and economic losses. So how do we do to make this, how do we proceed to make this quantitative? So for that to be quantitative, we need a model that will be a function of hazard, vulnerability, and or exposure, and that will give the impacts. And we need to build what we call pertinent counterfactuals. So you will have counterfactuals as in a word that could have been, a counterfactual is a word that could have been. And some counterfactuals can be climate counterfactuals, so a word without climate change, and others can be more vulnerability or exposure counterfactuals. For example, a word with a different types of, for the fire weather, different types of trees or different types of weather forecast, or like something that you can put in the model. And here I'm going to give one example that's from Sebastian et al. And that was published in 2019, and it's once again about Hurricane Harvey. And it's an attribution to climate change and urbanization. And in here, we have the current conditions. So with Harvey's rainfall and the 2017 urban development. And then they have a counterfactual with the with the urban development, such as the 2017 development and what they call the baseline, which is the climate counterfactual. So 2017 development and harvest rainfall decreased by 15%. So that's what we usually do in extreme event attribution. And then we have another one that's baseline plus climate change. So in this case, they keep the harvest rainfall and they put it on the 1900 development, urban development. And then you have the baseline where you have no urban development and no increase in the harvest rainfall related to climate change. And they find these results. So here you can see a figure where they look at the percent increase in discharge volume and in-house to peak discharge for so compared to the baseline. So when you add climate change, when you add development, and when you add current conditions. And you can see here for each point corresponds to one specific gauge in their basin, their water basin. And you can see that most of the changes are related to urban development more than climate change, but that climate change plays a role. And if we look at the numbers here for peak discharge, what's interesting is that the role of climate change is an increase of peak discharge of 20%. The role of the urban development is 54%. And if we add those two up, we don't get to as high a number as the current condition. So the change related to climate change amplifies the change in discharge related to a change in urban development. They also look at, here you have for each point corresponds to a gauge, and you have the percent change in discharge at all those different gauges. And you can see the percent change related to climate change, to development, and to current conditions, so both together. And what's interesting here is that they simulate without reservoirs, which were implemented. I don't remember exactly when, but there are reservoirs there, and with reservoirs. And those reservoirs are situated where you have those lines here. And you can see that reservoirs are helping to decrease the change in discharge, but only close to where they are situated. So they work for a certain area, but when you get far away from the reservoirs, they don't change this change in discharge that's related to climate change, development, and both of them together. So how this framework would help, I think if it's used cleverly, it can help to define better how mitigation and adaptation interact when we're looking at specific events that are impactful. It can help to point out boundaries where adaptation is not enough. So some of the counterfactuals can be adaptation solutions, for example, and can also help to highlight maladaptation. So showing how some adaptation solutions or things that are already in place are making the problem worse. But I think it's also very hard to know how this kind of study can be used and by whom. I think I have a general question that goes with extreme event attribution, but I would say more generally any of our of the science that goes out into the media or that's like goes out of the academic circles. How do we evaluate the impact of scientific communication in the current geopolitical context? For me, that's a question I don't have an answer, but that's the paper that we wrote is a partial answer to some of the criticism that's been coming from communities that are not our community, so social, so STS, for example, and disaster risk management. To finish, there's a paper that by Jesse Ribot, with an anthropologist, and he talks a bit about this question of attribution and responsibilities, and the name of the paper is Violent Silence. So there's a question, because we cannot put all of the different possible causes when we do a study, but what do we silence by highlighting specific parts of anthropogenic activity? And how does it impact the way that our science is used and helps to frame the climate problem? I think that's an important question for us as a community. And I will stop here. Thank you for your attention, and I'm happy to answer any question.